Okay, this is the Interstate F43 high voltage function generator. In the world of function generators, high voltage means that it puts out something over 10 or 15 volts peak to peak. This one will do 40 volts peak to peak into 50 ohms. But we don't need that capability of it. I just want to point out to you its controls. Here's the frequency multiplier and the frequency setting knob. Here's the trigger mode. We're in continuous, of course, because we just want it to run. Oh, but over here's the waveform selector. And you'll see that it's got a variety of waveforms with adjustable duty cycles here. You get a square wave crossing over the center, the zero line, or a square wave pulse above the zero line, or a square wave pulse completely below the zero line, with variable. The little orange band there indicates variable symmetry, so I can control the duty cycle by the inner pot of this knob. But for our purposes right now, I've got the function generator set to output DC. So it's actually not pulsing, it's just putting out a steady DC voltage level. Okay, and we've got the attenuator set to 0 dB, so no attenuation, and then this knob then will control the output amplitude of the function generator. And if we were putting a pulse in, this would control the peak-to-peak amplitude of the pulse. But since we're controlling DC, we'll see here on this knob, we'll see 0 to 5 volts of range, and we'll set the actual level of the DC output with the offset control. Okay, follow all that? We're not going to worry about the step calibrator or any of the fancy other functions of this nice old Interstate F43 function generator. This, incidentally, is the calibration sticker. I realize that it's been a while since it's been calibrated, but it has been calibrated at one point in its lifetime to NIST traceable standards, for whatever that's worth at this point. Okay, now over to the oscilloscope. Just demonstrating the function generator. So I've got the function generator going directly into the channel A, and then the function, and then extending on out to the clip leads, black and red. The black goes to the ground or sheath of the BNC connector, and the red goes to the center lead of the BNC connector. These are the leads that are referred to as positive and negative function generator outputs. Okay, now I've got that channel turned off. You see it's ground, and I've got the 0 baseline set to the exact center of the scope, and we're looking at 5 volts per division with no attenuation. Function generator output's just going right in there. So I'm going to go ahead and turn the channel on now to DC coupling. Okay, and you see that little jump up there from the baseline to about 2.5 volts. That's because I got the attenuator of the function generator set about halfway. So we're putting out a positive 2.5 volts. I can turn this attenuator all the way down. You see we go to 0 volts, and I can turn it all the way up, and we go to plus 5 volts, right? So I'm going to turn it to 2.5 volts output, just like that. So I'm asking the function generator to put out about half of its possible power by turning it to about halfway. Okay, now I'm going to vary the offset. Sorry about the light. I'm going to pull the offset control out, and I'm going to use the offset control to vary the offset. And as you can see, I can go from 0 offset, where the function generator is putting out no voltage. There's no difference now between the two terminals of the function generator's output. I can go up, plus 5, plus 10, plus 15, plus 20. Like I said, I can go to 40 volts with this function generator. Okay, but what I'm going to do is just take it down to minus 5 volts. Down. Okay, so we got 0, minus 5 volts. Alright, now the function generator is putting out a straight DC level of minus 5 volts. Right? What does that translate to at the terminals? Well, okay, here's my LED pair right here. Alright, I got a dropping resistor, I've got the two LEDs soldered together, cathode to anode, anode to cathode. And I guess I don't know how to prove that to you except show you where the flat spots are, because you can't see into the LEDs, or can you? Maybe you can, I don't know. The cup's the cathode. So there's the cup facing to the right on that LED, and there's the cup facing to the right on that LED. So as we turn them around, they mirror imaged, right? So those two are back to back, anode to cathode, with a dropping resistor on one end. Alright, now I haven't made any changes in anything. We're still putting out the minus 5 volts DC. Right? So now I'm going to put this under my chin and hook up the LEDs. Like that. I don't know, can you see that? Alright, so there. Can you see that? So one LED is glowing, right? See there? Here, let me do this here. Okay. So we got one LED of the pair glowing. And now, if I... how am I going to do this? Wait a minute. Here, let's see. Sorry, I haven't rehearsed this at all. Alright. So we got one LED on. Right? Let me turn this light off. Maybe that'll help. Okay. One LED on. Can you see both of them? 1 and 2. Now I'm going to go to the function generator offset, and I'm going to go to positive 5 volts. See what's going on there? So it doesn't matter whether you have your function generator set to positive 5 volt output or negative 5 volt output. You're going to get 5 volts potential difference between the two leads of the function generator. Right? They just swap polarities. And if you want to put a pulse in there to see what happens, okay, let's go over here and let's select the pulse form that's always below the line, like that. Alright, and you can see that we're pulsing down there. I can go to 0 offset now, and let's go to something that will hold this. Okay, so there are your pulses, right, below the line. And look, one of the LEDs is pulsing. How could this be if the function generator's output is quote-unquote negative? It's negative with respect to the other lead, which means that the other lead is positive with respect to the first lead. They just swap positions. Now if I took this LED out and turned it over, it would still be the LED on this side with the anode facing the negative quote-unquote output of the function generator. And the LED would be lighting. Okay, because we're having it put out a negative. In other words, the negative lead becomes positive and lights the LED. Okay, thanks for watching.